Go ahead.
Good?
He just told me I was more or less square. Do you think I'm more or less than? Or equal to?
Solid circle or closed circle? Liquid circle? I don't know.
Alright. That is sitting. If the boys were here, they would tell you it's sitting squad. Thank you, Nico, for that. This video is going to be kind of a two-parter. This is a statistics video, although mean, median, and mode definitely fits in with other classes as well. Just any class where you're doing any kind of data information. And then I have to admit, I'm not going to find standard deviation by hand. I can do a video about finding standard deviation by hand if you want to see it. But like in a statistics class, generally, my students use calculators. And so you can have the calculator find standard deviation for you. And then we'll talk about z-scores, which you need standard deviation for. So we're going to start just real basic with mean, median, and mode. Okay. In that, you can also find quartiles if you're interested. You can also find range. You could find interquartile range. You can find variance. You can find standard deviation. If you have a collection of data, you can find lots and lots of pieces of information about it. So I'm just going to go through and, I don't know, create some numbers with data. All right, so one of the first things that my students struggled with on a test, and I think it just was because they hadn't practiced it in a while, is you need to make sure that you order your data from smallest to largest. That's going to give you your range, so it's going to tell you how low you went to how far you went. You also cannot find the median if you do not put the numbers in order. So I like to just find my lowest numbers, and then I put like little marks above to know that I've used them, because if not, I get to the end and I'm like, crap, did I use every number I was supposed to? When I'm working on a calculator, what I'll do is I'll count my set, how many pieces I have in my sample, and I'll make sure that that matches in my calculator number. So my lowest number is a 4, but notice I have 2 of them. Then I've got a couple of 5s. I've got a 6. I've got a 7. I've got an 8. I've got a 9. 7, 8, 9. I've got a 10. And I've got a 12. You could do mode before putting them in order, but you can do mode right now also. Mode is the most. In mode, you could have no mode, one mode, or multiple modes. So in this case, I have 2 4s and 2 5s. Those are the numbers that appear the most. So this actually has 2 modes. This has a mode of 4, and then it also has 5 as a mode. Okay. All right, now for median, median is like the middle, because it's the middle of a road, right? You don't want to drive over the median. That would be bad. In math, to find the median, you count to the center. So what I do is I'll go 1, 2, 3, 4. Now, notice, if I go here, I don't have any numbers in the middle. So if I'm looking for my median, I can't have 2 numbers, weirdly, because mode I can have 2, but median you can't. So what you do for one number, you just leave it. For 2 numbers, you take their mean, and that will equal the median. Okay, to find the mean, it just means average. So we're going to add these 2 numbers together. That's 6 plus 7, and that's 13. And then 13 divided by 2 is 6.5. Or you maybe realize that halfway between 6 and 7 is 6.5. So the median is 6.5. Okay, now for the mean, what you do is you sum up your values, and then you divide by your sample size. So you take each x value, these are the x's because that's your sample, and then you divide by how many of them you have. So you would take 4 plus 4 plus 5 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 12. I'm going to go by tens. That's a shortcut you can use with adding. So I've got 10. This gives me 22. That takes me to 30, right? So, and when I'm tired, it's harder. So it's been a very long day, so I'm tired. 32, right? I said that? No, 30. 40, right? 50. And now I've got 9, 7, and 4. So I've got 59. That'll take me to 66. And that'll take me to 70. Damn, I'm good. I didn't even do that on purpose. All right. Now, of course, I have to divide by the number of numbers I have. And you can double check me because I might have totally done that wrong. This is usually when I make my students check that I did not fail, and then they can judge me and tell me whether I'm wrong or not. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my mean is 7. That was pure luck. That was not planned at all. So good job, me. So I have a mean, which is the average value in the set. I have the median, which is the middle number in the set. And I have the mode, which is the number that appears the most. Okay? Now, for a z-score, so what a z-score tells you in statistics is it tells you how far away from the center you are. It tells you how many standard deviations away you are. The standard deviation is how far from center you are. And you can have 1 standard deviation, you can have 2 standard deviations. In statistics, when you're actually studying like data and material, you generally want your data within 2 standard deviations because anything beyond that is considered unusual, and it could even fall in like the category of outliers. So what you need though is you need a mean and you need a standard deviation. You usually use the population standard deviation. So most of the time, like if you came upon a problem with this, they would give you the population standard deviation, but you can use the sample standard deviation if they don't give you the population standard deviation. So mean, median, and mode, I'm going to keep my mean. I mean, I know I just erased it, but I'm going to keep it. And then I'm just going to make up a standard deviation. Standard deviation, what you do is you take your mean, so my mean, that's the lowercase sigma, which mine always looks kind of like a cursive U. Mine was 7. Your x values were those list of 10 that we had, and then your standard deviation, not your standard deviation, you're solving for standard deviation. What you end up doing is you end up taking x minus mu squared. You have to take the sums of those, you have to divide, and it's not complicated, but it's a long process, and I don't want to do it. So if I had my calculator, I would just input my 10 values into my calculator, do my stats, 1 variable statistics, have it give me everything. All right. So this is our mean. The fancy mu version of it. I don't know why I said sigma. Because I'm tired. That's a mu, not a sigma. Sorry, that's a sigma. This is normally your population mean. This normally stands for whatever values are in your sample. So these are like your sample values. And I know there's a better word for it, and I'm just too tired to think of it. And then this is your population standard deviation, is what that symbol means. That's a lowercase sigma. So the z-score tells you how many or how much standard deviation from your mean you are. And the z-score, you take your x value minus your mean divided by your population standard deviation. So we'll say our sample values, say our x's are, I don't know, 5, 7, 12, I don't know, let's pick something crazy, 22. And let's say my population standard deviation is something really simple like 2. Usually because it's data, they're not going to be whole numbers. There's usually going to be decimals involved. But like I said, I'm doing this just kind of simply. I don't have a calculator or anything. And you can calculate the z-score for every single one of these and then talk about whether they fall within usual or unusual. So the z-score for this first one would be 5 minus 7 divided by 2. That's negative 2 over 2, which is negative 1. So what that means is this value is 1 standard deviation below my mean. I know it's below because it's a negative, and I know it's within 1 standard deviation or at 1 standard deviation because it actually equals 1. That makes sense because if I take my mean and I add 1 standard deviation, that's 7 plus 2, which is 9. If I subtract 1 standard deviation, that takes me to 5. So within 1 standard deviation of my mean would be between the numbers 5 and 9. So not very far off of average. So this is pretty usual because unusual would be 2 or greater. All right, now 7, hopefully at home you're shouting out very loudly, but basically that is the mean. And what you'll see then is this is literally 0 standard deviations away from the mean because it is the mean. All right, then you would do 12. That's obviously very usual because it is the mean. Then we do 12 minus 7 over 2. That's 5 over 2, which is 2.5. This is now an unusual number. It should not be usual within my set of values because it is 2.5 standard deviations away from the mean. All right, so 22 should be really, really unusual. So there I would take 22 minus my mean over 2. Oh, 22 minus 7 is 15. Does that sound right? 15
Yes.
plus 7, yeah. And 15 over 2 is 7.5. That's a ridiculous amount away from your mean, 7.5 standard deviations away from your mean. In my guesstimation, that number would probably be an outlier in my data. All right, an outlier is a multiple of your IQR. I'm too tired to think of what multiplier of your IQR it is. But what you do is you find your quadrant or your quartile 3 and your first quartile, and you subtract them, and then you multiply times, I don't remember right now. I'm sorry. It's been a very long day. Today was the day of a million years in a short amount of time. No. A regular like school day, but it felt like a million years. Anyway, so z-scores are really, really easy to find, and they just tell you how many standard deviations you are away from center. And anything greater than 2, either positive or negative, so anything above 2 or technically below negative 2, puts you in an unusual area. All right, so if you have questions about mean, median, mode, or z-scores, or there's something else you want me to cover or to have up just so you can see it, the children would tell you, comment in the link below. Not comment in the link below. Jeez, oh, peezo. Comment in the comments below. If you want, you can subscribe, and you can get notifications, and you can thumbs up my video if you're into thumbsing up things. I don't know what that does for life. I don't really know what any of this does for life besides math. But if there are other things you have questions about or other things that you want me to upload and show you or have archived so you can see them in the future, just let me know. All right. My brain's hurt.